Lesson 22, Analyzing and Comparing Statistical Graphs. Data can be expressed in different ways. A bar graph uses vertical and horizontal bars to represent data. It says and, but really it should say or. A bar graph can either show vertical bars, which are like these bars that we have right here going up and down, which is vertical, or it could be horizontal. They could have shown the exact same thing and had the bars coming out from the y-axis. The question says, how many people were surveyed? Well, we can see very easily that 22 people like dramas, 36 people like comedies, 75 people like thrillers, and 18 people like cartoons. So all we have to do is add those things up. How many people were surveyed? So in your calculator or in your head, you can do 22 plus 36 plus 75 plus 18, which will give us 151. And it says which kind of movie was most popular. We can look at our bar graph and see that very, very quickly. The most popular movie is going to be the movie that has the highest or the tallest bar, which is this movie right here. That is Thrillers. A double bar graph shows groups of two bars side by side in order to compare two related sets of data. So, for example, it says Sal and Harry are both own sandwich shops. The double bar graph shows the total number of shops owned by the end of at the end of each year. What conclusions can be made? So we're just looking at this bar graph and we're trying to make some conclusions based on what we see. So this is a double bar graph because we have double bars at each time, and the blue bars are all Harry and the purple bars are all Sal. And you can see along the vertical or the y-axis that this is the number of shops, and across the x-axis or the horizontal axis are the years. So in 2001 we can see that Sal had 2 shops, Harry had 10 shops. Okay, so looking at the graph, what kind of things do you see? I want you to pause the video and write down some things that you see. So some things that I see when I look at this graph is, first of all, I see that Harry very quickly has more shops than Sal in every year except for 2004, where they are the same. I also see that Harry's shops number increase every year at a steady pace. I can also see that Sal peaks in 2004 and then drops back down. So those are just some different things that I see. I hope that you saw some of those things, maybe some other things as well. Example 2 says to find the age of members at the hiking club that occurs most often. Remember, most means mode. We're looking for the mode. So when we're looking at this stem and leaf plot, the stem, remember, is in the tens column and the leaves are in the ones column. And so, for example, this one with this 0 means 10. So it means 10, 10, and then 17. Okay? So the numbers on this side that occur most, we have 3 ones in a row right here, and that number means 41. So 41 would be the age that occurs most. Line graphs show changes over time. For example 1, a line graph would look like this. This is just, I created this looking at example 1. We see some of the things that we talked about. Harry's shops increase at a steady pace every year. They have the same number of shops in 2004, and we see that Sal had the most shops at any point in 2004 for himself, and that he dropped back down as well. On example 4, it says make a bar graph to compare the deposits and withdrawals. I want you to make your own bar graph using the table below. I am not going to go over this with you. I'm not going to create one. I want you to create your own. I will be checking to see if you've done this whenever it comes time to grade your notes. Last example. This is a very simple concept if you know the rule. Okay. It says the circle graph shows Art Online's total yearly sales by quarter. The total number, or the total amount of sales for the year was $20 million. Okay, total for the year. That means the whole was $20 million, the whole thing. So let's find the sales for each quarter. So we'll start with the first quarter. How many sales were there in the first quarter? So what we're going to do, we're talking about the first quarter. And in the first quarter, I know that there were 12%, okay, of the sales were at that time. So instead of saying 12%, I'm going to change that to a decimal. I know I can move the decimal 2% to the left, or 2 places to the left, excuse me. So I have 0.12 times that 20 million. And so in your calculator, you can take 0.12 times 20 million, and that's going to get us 2.4 million. So in the first quarter of their sales, they sold 2.4 million. So second quarter, we're going to do the exact same thing. And in the second quarter, they sold 32%. So I'm going to take that decimal place, I'm going to move it 2 times. So I know I'm going to take 0.3, not 3.32, excuse me, times that 20 million, because it's 32% of the whole. Of means to multiply. So take 0.32 times 20, that's going to be 6.4 million. And we can repeat this process for the third and fourth quarters. I want you to do that on your own paper and have that in your notes. Make sure that you've taken good notes. Lesson 23, solving two-step equations. If an equation has two operations, use inverse operations and work backward to undo each operation one at a time. We should remember that inverse means that they are opposites and that they undo each other. And to reverse the order of operations, first add or subtract, then multiply or divide. Okay? So, for example, it wants us to evaluate. This is taking us back to stuff that we already know how to do. So we have 5, and instead of x, we're going to put 2 plus 4. Order of operations, I would multiply before I add, of course. All I have is multiplication and addition. So 5 times 2 is 10, plus 4 gives us 14. Alright, on B, however, they want us to solve. So whenever we do this, we are trying to get x by itself. So I am not looking at the side without x. I'm only looking at this side that has x. And I want to move the farthest thing away from it that's on the same side. This is the equal sign, okay? I want the farthest thing away from x that's on the same side. So I'm only looking over here. And the farthest thing away from x but still on the same side is plus 4. That's what I'm going to move first. So instead of adding 4 though, I'm going to subtract 4. And what I do to one side of the equal sign, I must do to the other. At this point, plus 4 and minus 4, those will cancel. They're opposites. So that would be the same as just adding 0, so we say it cancels out. I'm left with 5x on the left side. Has to be equal to, and I have 14 minus 4, which is 10. And then I have 5 times x. The opposite of multiplying is dividing. I'm trying to get x by itself, so I'm going to divide by 5 on both sides to get x by itself. 5 over 5 will cancel. I'm left with x equals 2. These two things go together. This one shows us that normally if we use order of operations, we follow multiplication then addition. On this one, we do inverse order of operations. We work backwards. So we're subtracting first, and then we're going to do the multiplication or division. Solve the equation, then check the solution. So on A, we're trying to get r by itself, so we're only going to look at the side that has r. So I'm going to draw my imaginary line on the equal sign there, so that I know that I'm only looking at the same side as r. The r is on the left side, so I'm not paying any attention to this 42 right now. I have 6r plus 12. The farthest thing away from r is the 12, and it's being added right now. So the opposite is going to be to subtract. What I do to one side, I must always do to the other. So I have my line for the equal sign. I've done it to the left side of it. Now I have to do it to the right side. So I'm going to subtract 12 over here. 12s will cancel. I bring down my 6r. Equals, come straight down. 42 minus 12 gives me 30. And now I just have that one-step equation that we've already been working on. So 6 times r, the opposite would be to divide. So I'm going to divide by 6. What I do to one side, I must do to the other side. So I'm going to divide by 6 over here. And remember, we're trying to get r by itself, so we're leaving r alone. A lot of times we get confused and we try to divide by r, or we're subtracting r, or whatever. We want to leave that variable alone. We're moving everything else away from it. So that will cancel. I have r, bring down my equal sign, and 30 divided by 6 is 5. Now it wanted me to check it. To check it, I'm going to say that r equals 5, so I'm going to substitute that back in. So I have 6 instead of r, I'm going to put 5 plus 12, and that should equal 42. So, order of operations over here, I have multiplication and addition. I'm going to multiply first. So 6 times 5 is 30. Bring down my plus 12. Bring down my equals 42. 30 plus 12 equals 42. 42 equals 42, which means, well, and that looks like a 2. Which means if that checks, it is correct. I want you to pause the video and try B on your own. On B, we have the exact same situation that we've had before, except for they put the variable on the right hand side. That does not change what we're going to do. We are still only looking at the side that has the variable, which this case is the right hand side, and I'm going to move the farthest thing away from the variable. The variable here is q, negative 4 is touching it, and then I have plus 8. That plus 8 is the farthest thing away, so I'm going to subtract 8. Now, this is where we really start to get confused. Please make sure you're taking good notes. What I do to one side of the equal sign, here's my dashed line, I've done it to the right side, now I need to do it to the other side, which is the left side. So I'm going to do the exact same thing. I subtracted 8 here, I'm going to subtract 8 here. So, 32 minus 8 is going to give me 24. My equal sign comes straight down. I have negative 4q. And then plus 8 minus 8 cancels out. So to get q by itself, what I need to do is the opposite. Negative 4 is being multiplied by q, so the opposite would be to divide. And remember, I'm leaving q alone. So negative 4 over negative 4 is going to cancel, and that's what I've done to the right hand side. I must also do to the left, so I'm doing the exact same thing. So 24 divided by negative 4 is going to give me a negative 6 equals, and I'm left with q. So to be technically correct, we should probably say q equals negative 6. To check that, we just have to plug it back in and solve. We're going to keep moving though. On this one, solve and check. This is something that I'm just going to show you a little trick on how to keep yourself from having to do common denominators, because I know that as soon as I turned the page here and you saw that there were fractions, you went, fractions? I don't know how to do that. Okay? Yes, you do. And I'm going to show you a quick way to get rid of those fractions so that you don't have to worry about it. And what we do to get rid of fractions is, as long as our variable is in the numerator, then we can get rid of the denominator once we've found a common denominator. So first of all, this 2/5 x is the same as saying 2/5 times x over 1, which is the same as saying 2x over 5 minus 1/4 equals 3/10. Okay, a common denominator between 5, 4, and 10 is going to be 20. If you didn't know that off the top of your head, it's fine. You can punch it into your calculator and figure one out. It's perfectly okay. But what I need to do now is get that common denominator in all three of these fractions. So to get 5 to be 20, I have to multiply by 4. Well, what I'm going to do is what I do to the bottom, I must also do to the top. So when I do that, I multiply straight across here. So 4 times 2x is 8x over 4 times 5, which is 20, minus, to get this one with a denominator of 20, I have to multiply by 5, top and bottom, because what I do to the top, I must do to the bottom. So 1 times 5 is 5, and 4 times 5 is 20. Equals, to get 10 with a 2, excuse me, to get 3/10 to be a denominator of 20, I must multiply that 10 by 2, and what I do to the bottom, I must also do to the top. So I have 3 times 2 is 6, over 10 times 2, which is 20. Now, do I have a common denominator? Yes. Is my variable in the numerator? That means it's on top. Yes. Once that happens, I can eliminate that denominator. So I have 8x minus 5 equals 6. This is a problem that we've been learning how to do this lesson. No fractions needed. We've gotten rid of that. So to get x by itself, I'm looking at only the side that has x, which is the left side of the equal sign. This negative 5 is the farthest away, so I'm going to do the opposite, which is to add it. What I do to one side, I must do to the other. Okay, so I'm left with 8x equals 6 plus 5 is 11. So 8x equals 11. 8 is being multiplied by x. The opposite would be to divide. So those will cancel. I'm left with x equals 11/8, which you could also reduce to be 1 3/8. Okay, final answer. Last problem here. Perfect painters will charge $25 for paint and materials and $25 per hour to paint the room. Classic painters will charge $250 to paint the same room. How many hours will it take for perfect painters charge to be the same as classic painters? So, what we need to do is we need to set up an equation. Perfect painters will charge $25 for paint and materials and $25 per hour. So we know that Perfect Painters is automatically charging this $25 just for the materials, plus they're charging $25 per hour. So for the first hour it's $25, then plus the $25 for the materials. The second hour I'm going to take 2 times the $25 per hour to get $50 plus the $25 for materials. So I'm going to represent this by saying 25H. Okay? This is what it's going to cost for Perfect Painters. Classic Painters will charge $250 to paint the same room. That's their flat fee. They came in, they said it's going to cost you $250 for us to paint it. They want to know how many hours it's going to take for these to be the same. If they're the same, they are equal. So we need to see how many hours it's going to take for it to cost Classic Painters $250 to paint that room. So I'm trying to get H by itself. I'm only going to look at the side that has H, which is the left side. The farthest thing away is this 25. Now, don't be confused by the fact that there's not a sign in front. When there's not a sign, I automatically know that this is what kind of a number. I hope you're thinking positive, because that's true. The opposite of a positive is a negative. What I do to one side, this is what I've done to the left side, I must do to the right side. So I'm going to subtract 25 over here. This will cancel, so I have 25H equals 250 minus 25 gives me that 225. And now I need to get H by itself, so I have to divide because right now they're being multiplied, so dividing is the opposite. What I do to one side of the equal sign, I must do to the other side. It has to be exactly the same. So 25s will cancel and I get H equals 5, and I'm talking about hours.